So let's work on the quiz number 2 here. So the first problem is the distance traveled by a snail is described by this function. So find the average velocity. Average velocity is distance traveled divided by the time spent on it. So what you're going to end up with is s of 2. So 2 times 2 squared plus 2 times 2 minus 0, 2 times 0 squared plus 2 times 0 divided by, my bad, 2 minus 0. I was a little bit sloppy earlier, which is 2 on the denominator. So it's 8 plus, it's 12 minus 0 divided by 2. So we end up with 6. The average velocity is that. So in order to find the average instantaneous velocity, essentially you are trying to push for the limit. So the general idea is to find average velocity in the intervals. We want the intervals to include 1 but shrinking. So for example, 0.9 through 1.1, and then 0.99 through 1.01, and then 0.999, and then 1.001. So basically the intervals need to include the value of 1, but they are having smaller and smaller sizes. And find the limit of the value of the average velocity, right? So basically find a sequence of average velocities and try to observe the general trend and do an educated guess based on that. I'm saying that my piecewise function here is continuous, so in other words, it's 2x limit. It's a limit from the left and limit from the right should be matching with each other. So -1 minus f of x, and limit x approaches -1 f of x from the right. So in other words, you have limit -1 negative. From the left, it's 2x minus a is the same as limit x approaches -1 from the right. It's x minus 3a. In other words, it's 2 times -1 minus a is -1 minus 3a. So in other words, -2 minus a is -1 minus 3a. 2a is 1, so a is 1/2. Okay, so to explain whether my function is continuous at the point of 2 or not, so first of all, I need to find my function value f of 2, which is 2 minus 3 times 1/2, which is 1/2. So secondly, I want to find my limit on the left side of 2. On the left side of 2 means I'm less than 2. It's x minus 3 times 1/2. So it is 2 times 3 minus 1/2, which is 1/2. And the other thing is 2 plus, so my function is 1 over x. In other words, it's 1 over 2, which is 1/2. Since they're equal to each other, so I can get to the conclusion, limit f of x as x approaches to 2 is 1/2. It's quite obvious that my function value and my function limit is identical to each other. So my function is continuous at the point of 2 as my final conclusion. In order to find the limit of my function by doing a simple substitution, it is 2 times 3 minus 3 over 3, which is 3 over 3, which is 1 as my final answer. The next problem, if I try substitution, I realize it's 2 times 1 plus 3 over 1 minus 1, which is non-zero over 0. So I end up with does not exist. And my last problem is continuous function, so it's just a matter of simple substitution. So I end up with sine of e as my final answer. Well, the next problem is asking you to read the graph. I want to find my left limit, right limit, and limit in general at the point of -2. So my right limit, clearly I'm approaching to the height of 4. My left limit, I'm approaching to the height of +1. And since the left and right limit don't agree with each other, so the limit doesn't exist, my function value approaches to 4. Sorry, my function value is exactly 4. So the limit of a function f of x at point x equals 2 would always equal to f of 2 for any type of function. It's not really true, otherwise all functions are continuous. It only works for continuous functions, right? So the limit of f of x is 2, then at the point of 2 is 0, then the left and right limit must be the same, which is exactly true. And it actually goes in both directions. So it leads to this, and it goes in the other way. So if we have my limit of my two terms to be both to be 0, then the limit of the division must be 1, which is technically force. Because I can take one thing as an example. If my problem's limit approaches f of x is supposed to be x minus 2 squared, and then you see another example where I have x minus 2, then it's quite obvious the limit of x minus 2 squared over x minus 2 is a limit of x minus 2, which is, as you can tell, 0, not necessarily 1.